This is question 5. Given that n is the smallest positive integer such that square root 3 plus I to the power of n is a real number a. If so, find the value of the floor function of n minus a. Note that square root 3 plus I can be written as square root 3 over 2 plus half I times 2. And square root 3 over 2 is equal to cosine pi over 6. And half is equal to sine pi over 6. And from the Euler formula, this can be written as e to the power of I pi over 6. If so, then square root 3 plus I to the power of n is equals to 2 to the power of n e I n pi over 6. Now, given that this is a real number, 2 to the power n is a real number, and in order to get this is a real number, the minimum value for a positive integer n should be equals to 6, so that this is equal to e to the power of I pi. And for information, e to the power of I pi is equals to -1. And they write as e to the power of I pi plus 1 equals to 0. And many mathematicians say that this is the most beautiful equation in the world because they combine the simplest number, that is 0 and 1, with the most complex number, that is pi, irrational number 3.14159, and so on and so forth, and e 2.718281828, and so on and so forth. I is square root of -1. So all these complicated numbers can combine together and be written as a very simple form as this. And they say that this is the most beautiful equation. Okay, back to this one. The minimum value for n is equal to 6. And in this case, this is equal to a. A will equal to 2 to the power of 6. And this is equal to -1. 2 to the power of 6 is 64. So with -1, -64. And therefore, n minus a, n is equal to 6 minus -64. This is equal to 70. 70 is the answer for question 5.